Okay, so we start our new lesson in Math 35 Integral Calculus, Techniques of Integration. Okay, so we have integration by parts. Let u and v be differentiable function of x. So the derivative of uv is equal to u dv plus v du from the product rule in differential calculus. So u dv is equal to the derivative of uv minus v du. Then the integral of u dv is equal to the integral of the derivative of uv minus the integral of v du. So that our integral of u dv is equal to uv minus the integral of v du. So this is the formula to follow when applying integration by parts. Okay, so let's try examples. We have example number 1, the integral of x sine x dx. Okay, so number 1, the integral of x sine x dx. Okay, so in applying integration by parts, we need to assign a value for u, du, v, and dv. So let u be equal to x. So our du be equal to dx. So the derivative of u is dx. And then integral of dv is equal to the integral of sine x dx, which is this one. Okay? So ito na ngayon si u dv natin. Okay? u dv, and then our v, the integral of dv is v. This is equal to, what is the integral of sine x dx? Looking at your table of formulas, that is negative cosine x plus c. Okay? So from there, since naka-assign na tayo ng mga variables, i-substitute natin tong mga to sa formula na the integral of u dv, which is this one, is equal to uv minus the integral of v du. Okay, so this will be equal to u, that is x, times v, that is negative cosine x, and then minus the integral of v, which is negative cosine x, and then du is dx. Okay, so simplifying, we have negative x cosine x, negative negative, that will be positive, and the integral of cosine x dx. So what is the integral of cosine x dx? That is, looking at your formula tables, that is positive sine x plus c. So the integral of x sine x dx is equal to negative x cosine x plus sine x plus c. So this is our final answer for example number 1 in integration by parts. Yung integration by parts kasi pwede siyang paulit-ulit na ginagawa until you arrive to the final answer. Okay, so let's try another example. Example number 2, the integral of ln x dx. So number 2, the integral of ln x dx. If you look at your table of formulas or table of integral formulas, walang direct, hindi siya, ln x is not directly integrated. That's why we apply integration by parts, and the function is logarithmic kasi. That's why kailangan nating mag-apply ng integration by parts. Okay? So when the ln x function is involved, automatically you apply integration by parts. Okay, so let u be equal to ln x, and du will be equal to 1 over x dx, tama? And then the integral of dv will be the integral of dx. So our v is equal to x, okay? So substituting this to the formula, we have the integral of ln x dx will be equal to u, that is ln x times x, okay? Ln x times x, and then minus the integral of v, and our du is 1 over x dx. Oh, 1 over x dx. So, simplifying, we have x ln x, hindi ln x squared ha. Si x is a different function from ln x. Okay. So, this will be equal to x ln x. So, we can cancel this one minus the integral of dx. So, this will be equal to x ln of x minus x. Okay. And then don't forget yung plus c natin. So this is the final answer for example number 2. Okay, so let's try another example. Example number 3, the integral of arctan x dx. Okay. So number 3, the integral of arctan x dx. Okay, so just like kanina na yung function na ln x natin, function ln of x, automatically apply IBP or integration by parts. Ganun din kapag sa inverse trigonometric functions like yan, arctan x, arcsine x, arccos x, and arccot x. So, if you see an inverse trigonometric function being integrated, then you need to apply integration by parts, okay? So, yun yung dalawang important cases when IBP is definitely the way to go. The logarithmic function ln x and the first four inverse trigonometric functions, which is the arcsine x, arccos x, arctan x, and arccot x. Okay. So, for this one, mag-let u tayo. Let u be equal to arctan x dx. Or I should say arctan x lang. Okay. And then your du, if you look at the table of differential calculus, the differential of arctan x is 1 over 1 plus x squared dx. And then our integral of dv is equal to integral of dx. So our v is equal to x. Applying yung formula for IBP, arctan x dx is equal to u, that is arctan x, and then v is x, minus the integral of v times c du natin. Dx, ayan. So, this is equal to x arctan x, and then this one will be, and for this one, this will be equal to minus x over 1 plus x squared dx. So, ang gagawin natin dito is to let's assign a variable. So, hindi na natin pwedeng gamitin si u and v. So, let's try naman m. Let m be equals to the denominators, which is 1 plus x squared. Then, our dm will be equal to 2x, since the derivative of 1 is equal to 0. So, this will be equal to 2x dx. Okay, so look at our function. Meron tayong x dx dito. So, pwede nating i-isolate si 2. so that ang matitira will be x dx, and whatever the value here, yun yung isa-substitute natin kay x dx dito in terms of m. Okay, so gawin nating a function of m yung function of x na to. Okay, so this will be equal to dm over 2, that is x dx. So we can now substitute. So this is equal to x arc tan x minus x dx is dm over 2. So this is the integral of dm over 2 over what is 1 plus x squared, that is m. Tama. And then we can isolate si constant. This will be equal to x arc tan x minus 1/2 integral of dm over m. So this is just like du over u. And the integral of dm over m is equal to ln m. Okay? So this is x arc tan x minus 1/2 ln of m plus c. And change natin si m sa function of x kanina. So this one. This is equal to x arc tan x minus 1/2 ln of 1 plus x squared. Sorry. X squared plus c. So, ito na ngayon yung final answer mo, final answer natin for example number 3. Okay, so dito sa IBP, hindi lang dapat kabisado mo yung mga basic integral natin. Okay, so please practice solving. And then, let's try another example. So, example number 4, x cubed times e raised to x dx. Okay, tapusin na lang muna natin sa 3 examples kasi yung next example natin is medyo mas matrabaho na. So, these are the 3 examples. The first 3 examples for the integration by parts.